Welcome back, Year 9, to the final lesson on linear relationships. Today we're going to be looking at graphical solutions for simultaneous equations. Now, we've done simultaneous equations before. We've actually covered some of the methods. There are three methods to solve lines simultaneously, and remember, when you're solving simultaneously, it's just a fancy way of saying, where do our lines meet? What's the point of intersection? Where's the coordinate that the two lines meet at? Now, there are three methods. We've used the substitution method. We've used the elimination method. This is the third method, and it's the one we want to avoid if we can, unless the diagram's provided for us. It's the graphical method. It's where you actually look at the graph to figure out where two lines meet. Now, in this example over here, this is a bit easier because I have one line going across this way, one line going down here, and I know they meet at that point there. Well, that point is across 1 and up 2, so they meet at 1, 2. That's easy to solve graphically because it's straightforward. But if I had a line that went like this and a line that went like that, where do they meet? Well, I'm not really sure how far left and how far down it is. I'd have to do a little bit of guesswork there, so that's where the problems arise. Let's just remember also that sometimes if lines are parallel, there is no point of intersection. So it's possible to get no answer sometimes if lines are parallel, because parallel lines never touch. All right, here's a problem. What if you draw a sketch like this? We've got two lines, we've drawn each line, and it says, find where they meet. Well, in this case they meet out 1.4, up 9.2. There's no way I can actually get that answer accurately from this sketch. So unless you're drawing graphical questions accurately, it's going to be quite challenging. Let's try the first one. Do those two lines meet at the point 1, 4? Well, you could graph them. And what would actually happen is this. You'd go y equals x plus 3 and you'd graph it, looks something like that. Y equals 2x plus 2, and you'd graph it and it's going to look something like that, and you'd check to see is that out 1, up 4, and it is, and you'd say yes, they meet at 1, 4. But I'm going to do this one algebraically by using substitution, because I think in this case it's easier. Let's have a look at this question. Now, let's substitute x equals 1 into this line. Now, where did I get x equals 1? I chose it because that's the x value of the point where they meet. So if I plug x equals 1 into y equals x plus 3, I get y equals 1 plus 3, which is 4. Hey, that's great because I wanted the answer to be 4 if I used x equals 1. That means 1, 4 is a point on this line. Now let's try doing the same thing for the line y equals 2x plus 2. Everywhere I see x, I'll put in 1. So instead of y equals 2x plus 2, it's y equals 2 times 1 plus 2. 2 times 1 is 2. Add 2 to that, you get 4. Hey, the answer is 4. Both lines pass through 1, 4, so both lines must meet at 1, 4. Let's try another one. Do these two lines meet at negative 2, 10? Let's do the same thing. Where am I getting minus 2 from? It says substitute x equals minus 2 into the first line. Well, minus 2 was chosen because that's the x value of the point I was given. So wherever I see an x, I put minus 2. So it's now y equals negative 5 times negative 2, which is positive 10, which is what I was hoping for. That means negative 2, 10 is on this line. Let's try that again with our second line, the line 2x plus 3y equals 25. Wherever I see an x, I'm going to put minus 2 in its place. Becomes 2 times minus 2 plus 3y is 25. 2 times minus 2 is minus 4. Now let's plus 4 to both sides. 25 and 4 make 29. Divide both sides by 3. And 29 over 3 is 9 2/3 or 9.6 recurring. That is not 10. And because it's not 10, the point negative 2, 10 is not on this line, which means those two lines do not both meet at negative 2, 10. Now you could have graphed them as well, but I think the substitution using algebra is a little easier for these ones. But now let's show how we do it if it was graphical. So if we have to graph y equals x take 3 and x plus y equals 4, you could use a table of values. Let's actually not. You could fill that in, but how many points do you need to know? I'll fill the table in first. For y equals x minus 3, if you use an x value of -2, -2 take 3 is -5. If I use an x value of -1, -1 take 3, -4, and you go through that process. But if I was doing this question for y equals x take 3, I would have just used 0 and 1. That would have been enough. And you would have got this. We can see that from this part of the table here. Similarly, for a question like this, I probably would have just found the x and the y-intercepts. Imagine covering up the x part, the y-intercept is at 4. Cover up the y part, the x-intercept is at 4. So you go to the y-axis at 4, the x-axis at 4, join them, and there's your line. But you could also go through the process of filling in the table. So if you rearrange this line by minusing x to both sides, y is 4 take x, 4 take minus 2 is 4 plus 2, which is 6. 4 take minus 1 is 4 plus 1. 4 take 0, 4 take 1, 4 take 2. You've got your two lines now. Here's your first line. I've plotted the points and joined them. Remember, you could have just gone to 0, minus 3 and 1, minus 2 and joined them, and you would have got the same thing. With my second line, if I plot the points that I get in my answer on the table, there they are there. Remember, I could have just used the x-intercept of 4 and the y-intercept of 4 and joined them together. Where do these lines meet? Well, they meet here. But what point is that? In the x direction from the origin, you've gone across 1, 2, 3, and it appears to me that you've gone across 3½ squares, and you've gone up half a square. So that point would be at 3½, a half. And that's how we solve our questions graphically. If we don't draw the graph carefully, it can be very hard to read the answer off. Well, time for you to try some questions. Enjoy. Bye for now.